Hello and welcome to Track Topper. In this video session, you're going to learn about the particle model of matter. So first thing, let's talk about the states of matter. As we all know that everything is matter around us, and matter exists in three forms. Number one is solids, number two is liquids, and number three is gas. So what is a solid, or what is the difference you can see as visible from this picture? You can see that in solids, the particles, they are very closely attached. They are just interlinked to each other very closely. So this structure, or this kind of an arrangement of particles in solids, give them a definite shape and a definite volume. That's why we say solids have a definite shape and a definite volume. In liquids, you can see the particles are a little farther apart. So they have some space to move around. As in solids, you see, they just can't move anywhere. They are so tightly packed. But in liquids, they are closer but not as close as in solids. So they are a little farther, so they have some space to move around. So that is a liquid. But they cannot leave that space and go anywhere. So they do have a definite volume, but they do not have a definite shape, because these particles, they can flow. And in gases, you see how far the particles are. So they are farther apart, like very far from each other. So they can flow, and they can even, gases is something like, if you fill up a gas, it can fill the entire container. So it doesn't have a definite shape nor a definite volume. So no definite shape and no definite volume for gases. This is something you have already learned in your junior classes. Now we are going to talk about the particle model of matter. What do we mean by particle model? That, like we have here, how the particles are arranged and what are the consequences of such an arrangement. So let's talk about, first of all, solids. As you've just seen in that image, what would we say about the particle arrangement? That particles are so close that there are almost negligible intermolecular spaces. So there are negligible intermolecular spaces. So they are so close, we do not have the intermolecular space between them. And this gives rise to a very strong intermolecular forces. Right? So the intermolecular spaces are almost zero, but intermolecular forces are strongest. Now the same thing if we talk in liquids, the particles are close, but particles have some space between them. So the intermolecular spaces are there, better than the solids, but less than the liquids. So I will say more than solids and less than liquids, right? So particles have some space between them, which is more than solids, but it is definitely, sorry, not less than liquids, less than gases. So this is less than gases. And if we talk of the intermolecular forces, so intermolecular forces are weaker than solids, but definitely more than gases. Because you can see that how the particles, they are little farther, so they are still attached to each other. So they do not leave each other and go. So they do have a molecular force, intermolecular force, that it is not as strong as solids. Then if we go to gases, the particle spaces are too high. So particles are far apart, and we would say large intermolecular spaces. Right, so if we talk of intermolecular spaces, that are largest in gases. But if I say the intermolecular forces, they are the weakest. So weakest intermolecular forces, or rather we would say negligible intermolecular forces, I would write the bracket, it is negligible. So these are the 2 points on the basis of which we discuss the difference between solids, liquids and gases on the basis of particle model. Particle spaces, the intermolecular spaces are negligible in solids, and largest in gases. Liquids have in between. And intermolecular forces, they are strongest in solids and negligible in gases. And liquids have forces in between the solids and gases. After learning about the three states of matter, the next important thing that you should know is a quantity called mole. So mole represents the quantity of matter. Like if you just compare it with a dozen. So if I tell you, you buy a dozen of bananas, 1 dozen would mean 12 bananas. So similarly, 1 mole has a specific value. It is not as small as 12. 1 mole is 6.022 times 10 to the power 23 atoms, or 6.022 into 10 raised by 23 molecules. And we call this number as Avogadro's number. So we usually denote capital N to denote the Avogadro's number. So 1 mole of anything. So if I say 1 mole of atoms, then that would refer to 6.022 into 10 to the power 23 atoms. So let's say I'm talking of 1 mole of sodium atoms. So it will be 6.022 into 10 raised by 23 sodium atoms. But if I say 1 mole of hydrogen molecules, so 1 mole of hydrogen molecules will be 6.022 times 10 raised by 23 molecules, but not atoms. If I want to find the number of atoms in this, I will just simply multiply this number with 2, because one molecule, each molecule contains 2 hydrogen atoms. So if I want to find out the number of atoms, I would rather multiply this with 2. So 2 times 6.022 into 10 raised by 23 atoms. Right? And another important thing you need to understand here, that though all moles have the same number of particles, but they don't all have the same mass. Like if I talk of sodium, so 1 mole of sodium atom would weigh how much? 23 grams. Then 1 mole of oxygen atom would weigh 16 grams. So though they contain the same number of particles, 1 mole of sodium or 1 mole of oxygen atoms are both 6.022 times 10 to the power 23 in number, but their weight is going to be different. Their mass is going to be different. Let's have a look at this question, which says if a mole of carbon has a mass of 12 grams, then how many atoms of carbon are there in 2 grams? So this we are going to use a simple unitary method of mathematics. If 12 grams is the mass of a carbon, which is 1 mole, that will be 6.022 into 10 raised by 23 atoms. So 12 gram is the weight of 6.022 into 10 raised by 23 atoms, because that's the weight of 1 mole, and 1 mole represents this number. Therefore, what will be the number of atoms in 2 grams? So 2 grams would contain 6.022 times 10 to the power 23 divided by 12 times 2. So you just divide it by 6 and you get 1.004 times 10 to the power 23 atoms. So 1 mole of carbon whose weight is 12 grams. Then what is the number of atoms in 2 grams of carbon? 12 grams of carbon is 1 mole, that is Avogadro's number of atoms. So 2 grams would be, you'll just do that, you divide by 12 and multiply by 2 and you get this as the number of atoms. That's all for this video session. In the next video session, you're going to learn about internal energy and specific heat capacity.